Oh, I have to introduce you to my favorite student. Good old Anne Surkey. She gets everything right. It's great. I don't get it. Think about it. Number 1. Prith just figured it out. There you go. Ryan still. Taylor will explain it to you later. Write in scientific notation. By the end of this year, Megan, you should be very comfortable flip-flopping. In fact, almost seeing both numbers, both forms of the number in your head at the same time. What is scientific notation? So the rule is only one digit before the decimal. So the decimal is going to go there. I write the non-zeros. Times 10 to the what? Well, the decimal was originally here. Now it's here. 1, 2, 3, 4. The way I would mark this, I would give you a half mark for the 1.23 and then a half mark for the times 10 to the 5th. If you got it right, you get 1 out of 1. B. I so frequently forget that stupid negative. I'm even going to do that just to remind my. It's decimal number negative, small number negative. All right, it's going to be 1, and I moved the decimal from here to here. 1, 2, 3. In fact, the exponent -4. It's the number of zeros plus the first digit every time. If you're looking for a little trick or whatever, I've at the point, John, where I glance at that and I know it's going to be 10 to the -4, and I don't actually have to count. I can just figure it out, right? Mr. Dueck, would that be okay? Sure. Would 1.0 be okay? Since I didn't say anything about sig figs here, sure. But that's extra writing, and why would I do that? .5. I'm going to move the decimal from there to there. 1, 2, 3, 4, 5, 6 zeros, and I count the 2, 7. 2.5 times 10 to the -7. Again, half mark for the 2.5 and a half mark for the times 10 to the -7. 7.8062 times 10 to the 1, 2, 3, 4, 5, 6. Oh, also to the 7, but positive 7. Number 2, perform the following operations on your calculator. Check. Oh, use the correct number of sig figs and express your answer in scientific notation. I read the instructions. Gotcha. So, I'll go to my calculator. Your calculator. There you go. Opening, 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 opening. Come on. There we are. 5. Scientific notation button 4. Mr. Dueck, you didn't do the brackets. You'll learn, and in this case, the brackets are redundant, and you'll get a good feel for when they are and when they aren't. Usually, if you're multiplying, the brackets are redundant. It's when you're dividing, you got to be a bit more careful. Times 1.6. That's not the answer, because that's not in scientific notation. So I'm going to write this down. First of all, how many sig figs? Well, multiplying, the rule is how many sig figs here? 2. I don't care about that. How many sig figs here? 2. I don't care about that. So how many sig figs in my answer? 2. So if I had just said write the answer in standard notation, I would have done that. But they said in scientific notation, so I guess it's going to be 8.0, because that's 2 sig figs. If you're missing the 0, half mark off, times 10 to the, I guess, 1. Mr. Dueck, do we have to put the 1 there? No, if you leave it blank, it's assumed there's a 1 there. The only reason I have a habit of putting the 1 there is I've learned over the years, if I do that, kids think there's a 0 there for some reason, and that's a different number. So I'll put it in. But, Haley, you don't have it. B. How many sig figs? 2. How many sig figs? 2. I'm going to go to 2 sig figs. 1.5 negative 5 divided by 3.5, 8. How many sig figs? 2. There's the first sig fig. The second sig fig is this 2. Is it going to stay a 2 or become a 3? 4.3, that's a half mark, times 10 to the, and again, I've learned on my calculator, when I see that little e, that means times 10 to the negative 14. Half mark for the times 10 to the negative 14. Adding and subtracting is much more difficult for sig figs. The nice thing, Ty, is 99% of the time this year, we're going to be multiplying, so we're not going to care. Mr. Dueck, how do you add and subtract with scientific notation? You really don't. You need to write this as 0.00075. Ryan, 10 to the what? 10 to the what? Say it again. You're right. 10 to the what? Say it one more time. 1, 2, 3, 4. The 7 is the 4th digit. Plus 10 to the what? 1, 2, 3, 4, 5. And there's the 3. I've done that. Then I said what you want to do is line these up vertically. Lining up the decimal places. 1, 2, 3, 7, 5 plus 1, 2, 3, 4, 1, 3. Then we said, there's the first place that my question mark is. You know what? That's what I'm going to round to. I go to my calculator. 0.00075 plus 0.00013. I got an answer in scientific notation. Okay. So the answer that I got was 7.63 times 10 to the negative 4. Your calculator might display it, it might not. That's okay, I can write that. Ryan, picking on you again. 10 to the negative what?
4.
10 to the negative what?
4.
Draw a line. Equal. 1, 2, 3, 4. So here's what I got in standard notation, Courtney. Do I know everything in this column, Courtney? Say yes. Do I know everything in this column? Say yes. Here's the guess. I'm going to round to here. Is the 6 going to stay a 6 or become a 7? Okay, so final answer in standard notation would be 0.1237. Did they say leave my answer in standard notation? Holy schmoly! 7.6 times 10 to the negative 4. Half mark for the 7.6, half mark for the 10 to the negative 4. By the way, I used to make this question worth 2 marks because the amount of work involved there, Connor, is really worth 2 marks. But, sorry, I paused the video. I think I was saying, I used to make this worth 2 marks. It was killing kids, Matt. So 1 mark, even though the amount of work, yeah, should be worth 2 because it's a chunk of work. If you got that wrong, there you go. I know of no clean, easy way to do the adding and subtracting with yucky decimals. And I'm also realizing in the homework that I gave you, I don't think there was anything quite like that. I got that homework from online this summer. Someone else had made it up, so I'll add that for next year. Oh, wait a minute. I let you rewrite these quizzes and you can still get full marks and get this, and maybe rewriting it would be a good way to practice and learn from your mistakes. Yeah, I don't feel guilty then. I should put nasty questions on quizzes because the test should be the easy thing. Right? Right. Okay, good. Let's keep going. Perform the indicated operations with the correct number of sig figs. Now, did I say scientific notation here? So I'll take either, I guess, because I didn't say you couldn't. Didn't say you had to. But I will be fussy on sig figs. We're multiplying 2 sig figs, 2 sig figs. 0.15 times 0.0016. So you can either write 2.4 times 10 to the negative 4, which is 2 sig figs, or 10 to the negative what, Matt? 1, 2, 3, 4, or that. Either's fine. Those are 2 sig figs. B, 3 sig figs, 4 sig figs. How many sig figs? 3. Do the math. 40. By the way, do I really need to type 40.0? Is that going to make it? So I'm just going to go with 40 divided by 30. I'm not going to type point. Okay. 1 point. How many sig figs am I going to go to? 1.33. Did anybody write that in scientific notation? Okay. It would be 1.33 times 10 to the 0, because there's no tens. But that's a dumb way to write it, in my opinion. So 2 sig figs, 2 sig figs, 2 sig figs. 5.1 scientific notation button negative 5 divided by 6 scientific notation button negative 7. That's a fluke. How many sig figs is that? Anybody write that in scientific notation? Okay. 8.5 times 10, and I'll put the 1 there, but you didn't have to put the 1 there because it's implied, but I'd like to put the 1 there because, you know, nerd. Adding and subtracting. 5.06, 8.124. There's my guess. That's what I'm going to round to. That's what I'm going to round to, so it's going to be 13.18. Or 1.318 times 10 to the 1. But I didn't say write it in scientific notation. And again, I did show you in the homework that there was kind of a shorter way to do that by looking at the number of decimal places, and if you've mastered that, great. But when in doubt, fall back on the longer way. 615.824, take away 55.2. I guess here is my first guess, so I'm going to round to 1 decimal place to there. It's going to be 615.824 minus 55.2. I said I'm going to round to here, 560.6. Or 5.606 times 10 to the 1, 2. Either or. Is that it? That's it. Can you give yourself a lovely score at the top of the page out of 12, please? At the bottom, if you want, you can put marked by and your name. That's a lie. You marked your name's at the... yeah, some of you actually were going to write that, really? I know you marked your own. People. So, if you haven't finished this, make sure you finish this, but I always, today, will tell you the dumb punchline. What is the punchline? What did the ape think of the grape's house? He thought it was divine. Oh, grapevine. Ha 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 ha. Okay. And whom should you see at the bank if you need to borrow money? The loan arranger? The loan ranger? I will never claim that these are funny. In fact, the only reason I like these is they make my jokes approach being funny in comparison. Just saying. So it's kind of an ego boost that way. If you have them done, hand them in today. If you don't have them done, then you're going to have some homework for the weekend because we're going to be throwing more stuff at you. Lesson 4. Anybody need a calculator? I should have asked. Everybody has a calculator? We have a calculator, not a phone? Yes, I'm looking at the backward. You got a calculator, not a phone, Trev? Yeah? Yeah, you. Excellent. Today's lesson is called dimensional analysis. It's also often called unit analysis. How many of you love memorizing 15 or 20 different ways to do the same thing? How many of you just enjoy committing useless stuff to memory? How many of you are always saying, Mr. Dueck, I would rather memorize a different way to do everything you teach me? Got one. You're going to hate this lesson. I hate memorizing stuff that I don't need to memorize. You're going to find a common theme throughout this whole course is going to be, you're going to hear me say, Alex, don't memorize this. I'll show you how to figure it out. I'll give you one method, and if you start here, you can take 9 forks in the road and still end up with the right answer for whatever situation I throw at you. I think Alex, not Alex, but Alex, that's a much better way to learn. A much better way to learn. And it's going to start today. The method that I'm going to give you for unit analysis or unit conversion or dimensional analysis is going to seem complicated, but if you wrap your brain around it, it's all I've ever used. As a matter of fact, I was on a third-year calculus exam, and I was doing a related rates calculus problem. The question went something like this. You have a tank of 1,000 liters. Pouring into the tank is 60% salt solution, 40% water. Pouring into the tank, you have 50% salt solution. The tank is draining at 2 liters per minute. After 10 minutes, what percent of the tank will be salty? You could solve that with calculus. And I blanked. Oh, I still remember. And I got really clever. I solved it with Physics 11 unit analysis. My prof was, yeah, okay, that'll work. It's not how I would have. Okay, that'll work. This can bail you out. What we're going to be talking about is how to convert from one type of unit to another. You are, however, going to want your formula sheet out because I gave you the metric prefixes on the back. Why? Because you don't have to memorize those. Why would I waste my time making you memorize those? Yes? Quick look at money. So there are 2 main types of conversion questions. What I call one-step questions, usually metric ones. And then there's multi-step conversions. Okay? One-step questions I do pretty sloppy. And what do I mean by a one-step? Where you're starting with a metric prefix and you're ending up with no metric prefix. CCC in front of the grams, ending up in grams. CCC in front of the amps, ending up in amps. You're losing the metric prefix. And this method is pretty straightforward. This is going to be a straight substitution. If I want to convert 12 milligrams, sorry, 12, capital M is megagrams, I do this. I always, and this is going to be a method, start out by writing down what they gave me. What number did they give you? 12. Write that down. I'm big on that also, Megan, because if this was a test, I've written something down, I'm no longer as stressed, I feel better, I've learned. You're going to hear a lot of the time in the method that I'm going to teach you when we get to new questions. Hopefully, if I do my job right, you'll know how to start right away. Oh, Dueck says, write this down. And there, now you've got some, it's no longer blank, it's not as intimidating. So for unit conversions, Matt, I always start out by, I write what they gave me. I feel better. Now, this is a one-step conversion. We're going and just getting rid of the M. What is the M on your chart as a power of 10? Capital M is 10 to the what? That's going to be the answer. Now, notice, this is not scientific notation. It kind of looks like it because there's a 10. That's because all of our metric system is based on powers of 10. Darn it, I'm blanking on a name. Alicia. That's why I was blanking, because I've had to learn it wrong and right. Okay. By the way, if you see me staring at you and staring, it's because I'm trying to dredge your name up from the depths of my, sorry excuse for a brain. So, 12, I know that looks like scientific notation. Scientific notation would technically be something, decimal something, but I'm still going to use my calculator. But this time, instead of using my scientific notation button, I'm actually going to type this. So get your calculator out, and I'm going to go 12. I'm going to type times. I'm going to type 10 to the power of 6. 12 megagrams is how many grams? That many. You can write that, well, what, now here's usually my rule of thumb, I could write all of that out, or would it be shorter to write that in scientific notation? Then I'm going to write that in scientific notation because it's less work. That is the best reason to use scientific notation, not because the test question says write your answer in scientific notation, and I will for this unit do that, but for the rest of the year, if it's less work to write it in scientific notation, I'm going to write it in scientific notation. If it's less work to write it in standard form, I'm going to write it in standard form. Here, I'm going to write it like this. 1.2 times 10 to the what? 7 grams. So literally for a one-step conversion, I just replace the metric prefix with the power of 10 that it refers to. In other words, if you want me to convert 13.6 milliamps, I start out writing down what they gave me. Times. What's milli? I'll give you a hint. 10 to the -3. And I'm going to go to my calculator and literally type in 13.6, hit my times, hit my 10, hit my to the power of -3. Could I write that in scientific notation? Sure. Would it be more work to write that in scientific notation? Yeah. I'm going to leave it as 0.0136. Apparently 13.6 milliamps is actually 0.0136 amps. By the way, milliamps, like 13.6, is called the death current because that can cause your heart to fibrillate and kill you. Hashtag nerd trivia. It is. Two-step questions. Do you see what I mean by a two-step question? We're going from one metric prefix to a different metric prefix. Care to guess how many steps a two-step question is going to take? Very good. Very good. Care to guess how I'm going to start? I'm going to be even better than that. I'm going to write down the number and the units they gave me, because this is a bit trickier. I'm going to start out by going and this method that I'm going to show you involves building a fraction chain. I hate fractions, Mr. Dueck. That's like the math F word. Not the F word you're thinking of. No, actually, we can do some good with this. So I'm going to go like this. Times. This is called building a unit conversion chain, and this is what can dramatically drop the amount of stuff you have to memorize. If Sheldon, you wrap your brain around this, and I've been doing this for a while. Almost always my kids can wrap their brain around this. It's going to take a bit of effort to make the wrap is all. What units do I want to get rid of? It's meant to be really obvious. The ones that I wrote there. What units do I want to get rid of? It's meant to be really obvious. The ones that I wrote there. Kilograms. Okay? So, to get rid of it, I want it to, and I'll use a math phrase, cancel. To get it to cancel, it needs to be on the bottom of a fraction. Why? Because originally it's on the top. Up here, I'm going to put grams. The base unit, the fundamental unit. And next to the base unit, next to the fundamental unit, instead of writing a K, like I did here, what can I replace a K with according to your chart? Ten to the third or 1,000. Okay? What I have just done is gone from, if I cross out the kilograms to grams. Apparently, if I want to go from kilograms to grams, it's going to be 13.6 times 10 to the 3. But now, I want to get rid of the grams. How would I get rid of the grams? Well, where are the grams in this fraction, on the top or the bottom? Where will I put them in the next fraction if I want them to cancel? What do I want to end up with on the top? Look at my blank space there and see what units they want us to end up with. But micrograms down here in front of the base unit can be replaced with a number. 10 to the what? From your chart. Okay? And now what will happen? Grams will cancel. Look at the only units that are left behind. Micrograms. That must mean this is going to give me an answer, Alex, in micrograms. How? I'm going to go 13.6 times 10 to the third divided by, because this is on the bottom of a fraction, 10 to the negative 6. Now pause for a second. So our trick is going to be write down what they gave me. I think that's a great way to start. Cancel the first unit by putting it on the bottom, and then the rule for the rest is always replace the metric prefix with the number in front of the base unit. Let's type this in first of all. It's going to be 13.6 times 10 to the third divided by 10 to the negative 6. I have a feeling you're going to get an answer in scientific notation because I'm doing the math in my head and I'm getting a really big number. I think 13.6 kilograms is going to be several billion or even trillion micro. Oh, there you go. 1.36 times 10 to the 10th. 1.36. Now that's going to seem complicated. Trust me, if you wrap your brain around that, you're done. You can convert anything into anything. All you need are the conversion factors. We're going to do a few more. Number 4. This is a two-step conversion. Do you know how I know? We're going from one metric prefix to another metric prefix. How am I going to start out? I'm going to write down what they gave me, including the units. By the way, what's a lowercase nano? 2,000 nanoliters. And now I'm going to build a fraction chain. What units am I in right now? Nanoliters. I want those to cancel. Right now they're on top. How will I get them to cancel? Put them where in the next fraction? On the bottom. On the top, I'm just going to put the fundamental base units, in this case, liters. Oh, and I'm going to replace the nano with whatever nano is. Is it 10 to the negative 9? Yeah. I really haven't bothered memorizing them because it's a waste of my time. What that will now have done, John, I am now in liters. And if I just said go to liters, you could do it that way. By the way, I showed you a shorter way for one step, but this also works for one-step conversion. I don't want to stay in liters, though. What do I want to end up with, John? Megaliters. So I need these liters to cancel. Where are these liters right now? On the top of a fraction. So where will the liters be in the next fraction? In the... And on the top, megaliters. However, I can't leave it like this. Really what I'm saying, Lydia, is this is not a legitimate conversion factor. Megaliters and liters aren't the same thing, but I can replace the mega in the bottom with a number, and they are the same thing. What's mega? 10 to the? What am I going to do with that 10 to the negative 9? Times it or divide it? By the way, for those of you who are interested, technically there's a 1 there and a 1 there, and those aren't going to change my answers at all. I just tend to leave them actually blank. What am I going to do with that 10 to the 6th on the bottom? Divide. So it's going to be 2,000 times 10 to the negative 9 divided by 10 to the 6th. It's going to be 2,000 times, I think you're going to get a really small answer if my math is correct. Probably it's going to spit it out in scientific notation no matter what setting your calculator is on. Yeah. 2,000 nanoliters is 2 times 10 to the negative 12 megaliters. Oh, I did it in black. Let's be consistent. By the way, Alex, this two-step conversion method can also be extended to multi-step conversion. All that happens is your fraction chains get long, and each time you simply say, okay, what can I get my units into? Now I want those to cancel, put them in the bottom. What can I get my new units into? Now I want those to cancel, put them in the bottom of the next fraction, and hopefully eventually you can end up in the units that you want on top. And you don't have to memorize another method. 342.5 kilometers is how many millimeters? Okay. Guess how I'm going to start? And the units now. Write down what they gave. In fact, you know what? Write down what they gave me. Okay. 342.5 km. Colon, I want the kms to cancel. First of all, do you notice this is going to be a two-step or multi-step? Because I'm starting with k's and ending up with m's. I want the kms to cancel. Where would I put them in the conversion factor? Bottom. On the top, I'm just going to put plain old meters, except this is wrong. This is a lie. This is not correct. Kilometers and meters aren't the same thing. But what is kilo the same as? Kilo the same as? You can put a 1,000 or a 10 to the 3. That's true. That's legitimate mathematically. That would now cancel, yay, kilometers. This would leave us in meters. Do I want to stop in meters? No, no. What do I want to end up in? Millimeters. Okay, so I want to cancel meters. It's in the, by the way, it's in the top of this fraction, so where will I put it in the next fraction? Bottom. What if it was in the bottom of this fraction? Where would I put it in the next fraction to cancel it? On the top. There, you just figured something out without me having to tell you. Times, and I want millimeters, except this is not right. Milli is the same as what in front of a meter sign? 10 to the negative 3. So I guess kilometers to millimeters is going to be 342.5 times 10 to the third divided by 10 to the negative third. I think you're probably going to get an answer. You know what? Your calculator might fit this in, or it might be in scientific notation. Like, depends probably how good your calculator is. 342.5 times 10 to the third, or 1,000, divided by 10 to the negative 3. What's going to be shorter, writing that or scientific notation? I'm going to write it in scientific notation. So I'm going to write 3.425 times 10 to the 1, 2, 3, 4, 5, 6, 7 is 8, right? Yes? 342.5 kilometers, that's the same as 3.425 times 10 to the 8th millimeters, or if you want that as a number, 342,500,000 millimeters. Units matter. I will take marks off if you have incorrect units. I will. Or missing units. I will. Units matter. Put your pencils down, look up. Multi-step conversions using conversion factors. Building longer chains. Here's a great example. How many seconds in 1 week? Has anybody memorized how many seconds are in 1 week? Waste of brain power if you have. I don't know how many seconds are in 1 week. I'm going to figure it out based on knowledge that I already have up here because I'm a human being. How am I going to start? I'm going to start off writing what they gave me. What did they give me? 1 week. I'm going to write down. I'll use WK for week. I want weeks to cancel. Where am I going to put it in the next fraction? I don't know how many seconds are in 1 week. Does anybody know any way to break up a week? Is there something you have memorized that you all know how many of something are in a week? See, you all know that. But here's the nice thing. Weeks now cancels. In fact, now we are in days. Does anybody know how many seconds are in a day? No? Oh, who cares? I've never memorized that either. I do want days to cancel, so where will I put it in my next fraction? Since it's on the top, I'll put it on the bottom now. Can anybody figure out a way to break days into something smaller that we all know because we've grown up? Oh, sure. How many hours? 24 hours. Cool. Anybody know how many seconds in 1 hour? Now, some of you might, but even if you don't, no problem. I can go one step, I can go further. Now, I want hours to cancel because I want to end up in seconds. Hours to cancel, put the H on the bottom. Anybody know, what can I break hours up into? Minutes? What's the conversion factor? How many minutes are the same as 1 hour? And by the way, these are all technically little ones. We're saying 7 days is 1 week, 24 hours is 1 day, 60 minutes is 1 hour. Now that would cancel out hours. Hey, I'm not in seconds yet, but I'm nearly there. I want minutes to cancel. How would I cancel minutes? Put it where? There's 1 minute. I don't suppose anybody knows some way to break minutes up into seconds, do we? And you all know this. You don't need to memorize extra stuff. You've already got this in your brain. What's the conversion factor for minutes and seconds? 60 seconds. It's the same as. So I guess I'm going to go 1 times 7 times 24 times 60 times 60 divided by 1, divided by 1, divided by 1, divided by 1. Am I going to bother doing the divided by 1s on my calculator? No. Hey, how many seconds in a week?
604,000.
Sorry, what was the answer?
604,000.
604,800? That would be wrong. For the rest of the year, I will be fussy if you don't put the units somewhere. I can't fit them next to it. I wrote too big. Oh, wait a minute, Mr. Dueck. Wait a minute, Mr. Dueck. You have this lovely technology here. Oh, yeah, that's great. Here we go. Seconds. Cool. Don't you wish you could do it on your paper? By the way, if you feel like memorizing that there are 604,800 seconds in a week, knock yourself out, Rebecca. I really don't. Go ahead. But to me, I can derive that chain based on stuff that I have memorized without even meaning to memorize it. I know there's 24 hours in a day. I know there's 7 days in a week. Oh, I know how many days are there in a year. 365. How many hours are there in 1 year? Example 7. I don't know. I'm going to start out writing down what they gave me. What did they give me? 1 year, because I want to end up in hours. Times. What can I turn years into? Days? Sure. So, I want years to cancel, days. What's the conversion factor? 1 year is how many days? And that would go like that. Now, right around here, I think, I'm trying to remember, once in a while I've had a kid who's seen the musical Rent and actually knows how many minutes there are in a year or in a day or something like that, because there is a song to that effect. Hey, if you've seen that song and you've memorized that particular conversion, in fact, feel free to use it. I just haven't wasted my brain there. But anybody know the musical that I'm talking about? Is this right? Minutes. I know it ends in 1,000, but I can't remember the number anymore. Okay. Oh! Get rid of days. I do have a conversion factor for hours. What? How many hours in a day? 1 day, 20. Apparently, I'm just going to go Now, you may be saying, Mr. Dueck, I would have figured that out. If you can figure that out without building a chain, I have no problem with that. What I'm giving you, Sheldon, is if you ever have a question that you've never seen before, this will work for everything. Even for third-year calculus, if you're particularly clever in a pinch. It's going to be 360, well, 1 times 365 times 24 divided by 1 divided by 1, but I'm going to ignore the ones. $8,760 units, hours. How many minutes in 1 year? I guess I would multiply that by 60. I have learned to go from hours to minutes times by 60, so there I don't use a chain because I've done that one so often. I do have memorized a shortcut there. Fine. How many seconds in 1 year? Okay. Well, how can I break down a year? I can do days. Can anyone see how we can be more clever? We just did hours. We could go straight to hours. Good. Now, if you didn't have that handy, you could do the day, the same derivation we just did. But since we got hours, let's use it. So I'm going to go like this. I want years to cancel. What did we say? How many hours was 8,760? Just saved myself some writing. Yay! I want hours to cancel. Do I know how many seconds are in an hour? By the way, I do. There's 3,600 seconds, and some of you might end up memorizing that. And if you do, you can feel free to use that. I won't take marks off, but I'll assume you don't have that memorized. I'll say to myself, how about 60 minutes is 1 hour? And then to cancel minutes, how about 60 seconds is 1 minute? I think the number of seconds in 1 year is 8,760 times 60 times 60 times 1 divided by 1 divided by 1 divided by I got really clever. Since I had 8,760 on my calculator, I used my answer button, and instead of going times 60 times 60, I know that's the same as going times 60 squared. Feel free to be, learn to make your calculator sing a little bit. 31536 and 3 zeros. 31536 and 3 zeros. 31,536,000 seconds each year. And they're ticking away. And we waste most of them. This is the conversion factor method. It says, look, as long as I have some conversion factors, I can build a fraction chain. I don't need to memorize a particular method. This will work every time. It'll work with imperial, so here's a table of weights and measures. I stole this from somewhere on the internet. It had, hey, miles and hands and feet and, okay, townships and gills. And I don't know what any of these are. But I did say, okay, how many centimeters in 1 mile? You know how I'm going to start this? I'm going to write down what they gave me. What did they give me? 1 mile. By the way, would that be a good abbreviation to use for miles? Not in Canada, so how about that? Or you can write out the word mile, I don't care. Times. I want miles to cancel. Look at this chart. First of all, do they have miles to centimeters? Because if they did, I'm done. What can I convert miles into on this chart? Feet? Okay. 1 mile, this is why I hate the US units, is what? 5,280, what a stupid number, feet. I don't memorize that, that's a waste of my brain. If I really needed it, I'd Google it. Here I have it on a chart. But here's the good news. Yay. Can I go from feet to centimeters? Is that on the chart somewhere? I do want feet to cancel, so I'll put it on the bottom. Oh, I can go into inches? Okay. Is that on there, or do I happen to know that? I think this one I'm going to have to actually just know that 1 foot. I just realized I don't see that on the chart anywhere. I'm going to gamble and say, since you guys live close to the US, that you figured that out. On a test, I would give that to you. Why does that help? Well, I can cancel out inches. Oh, do I have a conversion factor for inches and centimeters? What is it? Apparently 1 inch is 2.54. By the way, this is why we like the metric system so much, because all the numbers are tens, right? Here, 2.54, 12, and 5,280. What a waste of brain power. But okay, apparently if I want to find out how many centimeters in 1 mile, it's going to be 1 times 5,280 times 12 times 2.54 divided by 1 divided by 1 divided by 1, but I'll probably ignore the ones. You get 160,934.4. I'm not going to worry about sig figs or anything here. I'll just write the whole thing. 160,934.4 units, centimeters. Did I put units on the last one? Mr. Dueck, you forgot to see how my subconscious was bothering me the whole time? I'd forgotten to put a seconds there. Jeez. I think we'll do this one, and then I may do the lottery question next class. But for now, 60 miles per hour in meters per second. Okay. Any suggestions on how I'm going to start? I'm going to write down what they gave me, which was what? 60 miles. Now, little advice, slashy fractions are terrible. I'm going to do a vertical fraction, and I'm going to put the hours like that so I can clearly see what's on the top and what's on the bottom. And it looks like here, this time, I'm going to have to do two things. Cohen, I'm going to have to get rid of the miles, and I'm going to have to get rid of the hours. I won't do them at the same time. I'll do one and then the other. Cohen, which one you want to get rid of first, miles or hours? Doesn't matter. Pick. Sorry? Where is hours right now, on the bottom or on the top of a fraction? So if I want it to cancel, where will it be in the next fraction? There you go, Captain Obvious. I want to end up my time units in seconds. Do you know how many hours are in a second or how many seconds are in an hour? Say no. What can I break hours into that you do have memorized? Okay, let's do that. So I'm going to go minutes on the bottom this time. 1 hour, 60 minutes, and that would do that. Sure. Now I'm in miles per minute. Do I want to be in miles per minute? No. What do I want the minutes to convert into? Seconds. I want the minutes to cancel. Cohen, where are they right now? In the bottom. So where will I put it? The minutes in my next fraction. There you go. Do I have a conversion factor that I have memorized for minutes and seconds? Why, yes. 1 minute, 60 seconds. If I just stopped here, this would give me miles per second. Okay? And it turns out 60 miles an hour is 1 mile a second. Hey. Now we got to deal with the miles. Where is the miles right now? So where am I going to put it to get it to cancel? There you go. What can I turn miles into? You know what? I'm going to walk through some of the same stuff I just did. 1 mile is going to be 5,280 feet. And that's going to cancel the miles. Now I want to get rid of the feet. Do I have a conversion factor for feet to meters? That would be wonderful if there was up there. Is there? Ah. What can I go from feet to? Inches. And what can I go from inches to? Centimeters. What can I go from centimeters to? Meters. There's, okay, I got my domino chain. I know how I'm going to do this. So, want feet to cancel. 12 inches, 1 foot. I want inches to cancel. 2.54 centimeters. Now, to be honest, I lied to you. I've taught this lesson enough times that I have now memorized that 2.54 centimeters is 1 inch. I almost wish I hadn't because I didn't mean to, but okay, so I can now go straight to there is 1 inch. Are you guys able to fit this on one line? I'm going to try. I'm going to do this trick again. Nope. Try that again, Mr. Dueck. Get the whole thing. And centimeters, 100. Is that how it goes? No, centi is 10 to the negative 2, isn't it? 10 to the, isn't it from your chart? 10 to the negative 2? Yes? Yeah. I'm so used to thinking 100, but no, it's actually dividing by 100. Apparently it's going to be 60. Now, I have also learned this trick. If you divide miles per hour by 2, that's roughly meters per second. Without doing any of the math, I'm going to tell you right now, you're going to get an answer like 25, 26, 27, or 28-ish with decimals. Let me try. 60 times 5,280 times 12 times 2.54 times 10 to the negative 2 divided by 60 and also divided by another 60. Yeah, I think. The rest are all ones. I said the answer was going to be like 26, 27-ish. Yay! 26.8. Next class, we'll look at, because you've probably wondered, how much money could you spend each day or each hour or each week if you won one of these? So we'll pick this up. Gloria McKenzie won $590.5 million May 18th. If she spends $1,000 per day, how many years will it take? If she spends $500 per hour, how many years will it take? And then actually she chose to receive a single payment of $371 million and paid no taxes because she lives in Florida. How many years would it take for her to spend this if she spent $10 per minute? And then we'll look at some Fermi problems. That's going to be next class. I do have a little bit of homework for you to get a start on.